Hello and welcome back to Calculus 2 section 8.4 on trigonometric substitution. So the way I'm going to present this is not in any of the books. Maybe there is, but I haven't found it yet. Generally in books they ask you to memorize 3 cases, 3 formulas, and then you get to do the trig sub. And then generally at the end it's just good luck to unwrap it back to x and so on. You are familiar with u sub from Calc 1, hopefully. And in the u sub, you transform x domain space into u domain space. And then you are able to integrate because the functions changed with the transformation. And then you bring it back to x. In some cases, you might even change the limits into u limits and compute the integral, get a number without going back to x. What we are going to do now is we are going to take good old functions that have x and transform them into trig. And then we are going to use the last class trigonometric integrals to solve these problems and then go on and deal with. So now, here are the formulas that you must know, otherwise this stuff is not going to go well. The first is the way to set up the triangle for trig, right? You have to know opposite, adjacent, and all of that. So this is angle theta. This would be adjacent side, which is the one touching the angle. Opposite side, one opposite to the angle, and the hypotenuse, the longest side of the right triangle. Right angle is always going to be opposite to the hypotenuse. Squared is equal to c squared. Now that one can be solved into c equals square root of a squared plus b squared. A equals square root of c squared minus b squared, and b equals square root of c squared minus a squared. So these are the 3. And we have to take a look at some patterns because our method, remember that I said I'm going to teach one method that works them all. Rather than learning 3 separate methods and then good luck. So what I want you to realize immediately is that when you have a negative sign, hypotenuse is always first. That's one of the key observations. And if you have a plus, it's legs that you have inside. So you have to remember that piece, that observation. So if there is a negative sign, its hypotenuse is first, minus one of the legs. And if it's a plus, it's 2 legs. That is key observation, guys. Now I'm going to get rid of this stuff because it's ruining my formulas here. And now we are ready to go and take a look at examples. There is nothing else. This is all of the trig and right triangle stuff that you need to know in order to set these problems up and transform them. Now the question is, how well do you know trigonometric identities to actually integrate? That's a different story, right? So this section will literally have 3 or 4 lines just to transform the integral into trig, and then 8.3 kicks in to solve the problems. So let's take a look at the integral of, let's say, square root of x squared plus 9 divided by x dx. So you're looking at this integral and you want to use this, you want to solve this integral using something basic, obviously, first. So you say it's not basic integral, so I can't do that. And then you say, how about basic u sub? X squared plus 9 equals u. Well, the problem is that the x is on the wrong spot. It's in denominator. So you can't use u sub because x is in denominator. You need x to be in the numerator in order for you to use u sub. So we can't use u sub. We can't use basic integration. It's not basic integral. And you also see that integration by parts won't work because you have 1 over x. You can integrate the derivative. No matter what you pick for the derivative will always make it worse with the next iteration. So nothing works, right? Well, luckily we can use this. Wait a second. We can use this new method. So we are immediately going to set up a triangle and write the trig functions using the triangle. Now here is that observation which I mentioned. Oh, if there is a plus under the square root, the two values given to you are legs. That's how you know x and 3 go on legs.
Is that one more time?
Because there is a plus under the square root,
Okay.
you have legs, which are a and b. And now, because they're squared, you just put the non-squared versions, so x and a 3. And then, by Pythagorean theorem, this one will be x squared plus 9. So you see the features of the problem inside the triangle. So now, you are going to create two trigonometric functions, always using the side that has a constant on it. So for the red one, I'm going to write the tangent. Theta is x over 3, from where x is equal to 3 tangent theta, and immediately dx is 3 secant squared theta d theta. I need to replace dx as well, so as soon as you calculate x from any of the equations, you immediately find dx so that you can plug that as well. So what I used here were the red pair of sides, and the red pair of sides gave me the red equations. So now I have x and I have dx to replace in my substitution for the problem. Now the next pair is the blue pair. So for the blue pair, I'm going to use cosine because it's adjacent and hypotenuse. So cosine theta for the blue pair is going to be 3 divided by the square root of x squared plus 9. Square root of x squared plus 9 is equal to, because that's what I need to replace, you solve for it, is 3 over cosine theta, and 3 over cosine theta is secant. So 3 secant theta. And that's good, because we know from the previous section and previous life, which is Calc 1, that tangent and secant are pairs. You don't want to pair tangent with a cosine. So tangent secant have to be pairs. And obviously, naturally, in mathematics, everything always clicks and works out just fine. So if you are not matching these functions, you are doing something terribly wrong. They always have to come up as a sine-cosine pair, secant-tangent pair, or cosecant-cotangent pair. And you will also learn that if you don't want to deal with a secant and cosecant, you just swap these two, and then it will work out to be secant-tangent. But that's later down the line. We are done. This is what I'm teaching tonight. Nothing else. Just that. That's it. The rest from this point on is the previous lecture to solve the integral. What do I have there? I have that black integral, right? Which has a square root, which will be swapped with a 3 secant. I have that x on the bottom, which will be swapped by 3 tangent. And I have the dx that will be swapped by 3 secant squared. See that? So the entire integral up there is changed into the trig functions, and that's the substitution piece. The rest is going to be your knowledge of trigonometric integration from the previous section. So now what do I have? I have the integral. Instead of the square root, I get to write 3 secant theta. Instead of the x, I put 3 tangent theta. And instead of the dx, I put 3 secant squared theta d theta. And our lesson is over. All right? So no matter what you get, as long as you are able to use the square root to create a triangle and populate the sides, the rest is just going to be chasing through the equations what you need to plug in. And you should be looking at these as blocks. I have a block of square root that I need to replace. I have a block of x that I need to replace. I have a block of dx that I need to replace. And those blocks are all given in your calculations, and you just go and you replace, right? So you rip this out, right, and you cut and paste the piece in instead of it, because we have the triangle to connect the two worlds. And that's what we are dealing with tonight. Good night. I'm just kidding. Yes.
Can you see one more time what those trig pairs are?
Sine, cosine, tangent, secant, and cotangent, cosecant.
Okay, thank you.
Yes.
Could you leave the answer into the table? Or expect to...
No, we're going to go back to x.
Okay.
Huh. Leave the answer in tangent. Then no one cares about theta.
But nobody cares about...
Exactly. So, these 3's cancel. Kick the 3 outside. We have secant cubed theta divided by the tangent theta d theta. And now is just your knowledge of the previous section, which is why when you start preparing yourself for the exam number 2, which is tonight obviously, you are going to put 90% of your efforts in this section because it practices both sections at the same time. So now we have to somehow integrate this, and then we're done. And the tricks for integrating this are, remember, putting something in a bank for the substitution, or converting to sines and cosines, hoping basic U sub would do the work. So, what we could attempt here, so if I have, I can't do the tangent because I need secant squared in a bank, and that one secant stays. I can't. So let's try and convert to sines and cosines, see if that's going to help. So 1 over cosine cubed theta divided by sine theta over cosine theta for the tangent d theta. This one cancels with one of these. And we get 3 integral of 1 over sine theta cosine square. Holy nightmare, this one is bad. Theta. No, because it's on the denominator. This appears that it's not a way to do it. Okay, so what do? You walk away. Let's see. We can also write secant as 1 plus tangent squared theta divided by tangent squared theta. No, just the tangent. Right? And all of that needs to be multiplied by another secant theta d theta. So I took 2 secants and transferred them into tangents. So now this transforms into secant theta over tangent theta d theta for the first integral, and the second integral, so that will be a plus 3 because the 3 distributes to both integrals, obviously. For the second one, one of the tangents cancels, so I have tangent theta secant theta d theta. Okay, we can work with this, I hope. Secant divided by tangent over there is going to be 3 integral of, now secant is 1 over cosine, sine over cosine, so this is cosecant theta d theta plus 3, and the integral of secant tangent is just secant, so this is a basic integral if you pay attention. Now the issue with the cosecant obviously is that's the bad one from last time, so that's the ln of cosecant theta plus cotangent theta, or if you don't know it, you have to memorize that function to do it, which is even crazier, plus 3 secant theta plus c. Woohoo! But we're not done, because no one cares about theta. Gotta go back to x. The bad part, yeah, it was from previous lecture. This part, today's lecture, easy, straightforward, I hope. Set up the triangle, chase the functions for 2 seconds, you're done. Last class, hell on earth, right? So, they come together, right? The opposites attract. So now, I have negative 3 ln, and I go and I read the cosecant off of my triangle. Now, cosecant is 1 over sine, so that's going to be square root over x. So square root of x squared plus 9 over x plus cotangent. Cotangent is going to be 3 over x from the triangle plus 3 times, and then the secant is 1 over cosine, and that's going to be square root over 3. No, yeah, square root over 3. I remember the triangle. And now we can cancel the 3's and have this as negative 3 ln of these common denominators, so 3 plus the square root of x squared plus 9 divided by x plus square root of x squared plus 9 plus c. What a wonderful answer. So please, next time someone goes, what do you know? Mathematical gymnastics. If you plug this problem in Mathematica, it solves it in 6 seconds. Not even. Fraction of a second. But it's more fun to chase these things around. That's it, guys. So now what your homework looks like. Looks like that. A page of 100 integrals that you can just work out, which practices both sections at the same time. And if you are on MyMathLab, it's going to look the same. Do you see this feature of a square root everywhere? Or at least it has the exponent, like 3/2 over here. In problem 27, well, this is the old edition of the book, so it doesn't matter. The new edition has the same stuff. So let's pick another example. Something that, what did you say?
35.
35. Oh, spicy. I'm not going to put the number because it's old addition. So square root of 3 minus 2x minus x. Well, this doesn't look the same. What now? I know. What do we have to do here? Math? Can't break it up? Nope. Nope. Quit. Okay, what else? Complete the square. When you complete the square, it will give you. So, this is, I would say, a spice level 3 on a scale of 4. So, we could come back to this, or nah, let's just do it. Nothing you can. So we have negative x squared minus 2x plus 3. Factor out negative 1, have x squared plus 2x minus 3. To complete the square, you need plus 1. So minus 1, x squared plus 2x plus 1, and then you have minus 4 because you have to also subtract 1 to balance it off. And these puppies over here are going to go square root of the first, sine of the second, square root of the third, everything squared, minus 4. Excellent. And then we have all of that times negative 1. Now that negative 1 is just going to swap the spots for these. And there we have our brand new problem, nice and shiny. It is now given as the square root of 4 minus, and you have your x plus 1 over here squared. There you go. So now you can draw your triangle. It's a minus, and when it's a minus, what was the rule? Hypotenuse is first. So we get a 2 up there. So if you have minus under the root, hypotenuse is first, square root of 4 is 2, goes on a hypotenuse. Now x plus 1 you can put over here, or you can put on the bottom. You can swap them, whatever. So if x plus 1 is there, then this one over here is 4 minus x plus 1 squared. You have your red pair, you have your blue pair, always towards the number. Red pair is clearly, dare I say, sine theta, which is x plus 1 divided by 2, from where x plus 1 is 2 sine theta. And when you differentiate this, you get dx is equal to 2 cosine theta d theta. That plus 1 doesn't matter because derivative is going to kill it. You can put it on the left, on the right, no matter where you put it when you differentiate. Derivative kills it. So guys, I have dx. See, this formula on the bottom gave me dx to replace up there. And all I need to do is to work on a second one to have something to put in for the root. Well, that's going to be the blue, and that's a cosine. So cosine theta is going to be the square root divided by 2. So the square root is equal to 2 cosine theta. And I have all of my building blocks. The problem turns into the integral. Dx is 2 cosine theta d theta. And the square root turns into 2 cosine theta.
Wow.
I know, right? That's the integral of d theta. Answer is theta plus c. And you can now, for this theta, you can do inverse of any function you want. We can go here and say that theta is equal to inverse sine of x plus 1 over 2. So sine inverse of x plus 1 over 2 plus c, done deal. So for some of these problems, it's really scary to solve these integrals. For others, as you can see in this case, it's a joke. That was a good pick. Let's do another one because we can. Scroll up a little bit. There you go. A little bit more. Or you want to see the completing the square? The cosines? This stuff? I plugged in. So this dx is swapped by 2 cosine. And the square root also swapped by 2 cosine that I got from blue and red, right? Pick. It doesn't really matter. They're all the same.
I like number 40 because it says X. Basically.
Oh, that just gives you the domain of values that you're not allowed. So, you want that one? That doesn't really matter. They're all the same. All of the 100 problems, they're all the same. You draw the triangle, you do the red and the blue set of equations, you plug in, and then good luck with the previous section. Some of those you're going to solve in a split-second integration, and some of those you're going to, sit there, cry for a week, and then give up and use mathematics. So it's just what you get for the previous section. The first part is identical for every problem. So pick one. 16, I heard. Okay. So in this particular problem, we have 36 minus 9x squared raised to the negative 3/2 dx. Sneaky, sneaky. Sneaky, sneaky. Now, I am going to rewrite this problem so it's easier for algebra. I'm going to put it as a square root of 36 minus 9x squared, and I'm going to put a little 3 right there on the square root, because that's what the upper negative 3/2 is. Half is giving you a root, negative pushes in the denominator, and the 3 stays as the exponent of it. So now we immediately go and work out the triangle knockoffing. So we have the negative sign. If it's a negative, hypotenuse is 6. Good. And now we get to put 3x whatever you want. Pick one. Opposite it is, 3x. So now that means that this one over here is 36 minus 9x squared. Use the Pythagorean theorem. So now I am going to have the red pair and the blue pair. Red pair is a sine theta, which is going to be 3x divided by 6. 3 and 6 will cancel. So x is equal to 2 sine theta, and immediately dx is equal to 2 cosine of cosine theta d theta. So I already have dx to replace. The next one I need to work on is my root. So cosine theta is going to be root divided by 6. So the square root is 6 cosine theta. Great, we're done. Well, not quite. You're going to say, but it's cubed. Okay, fine, you win. I'll cube here, and here, and here, and now we're all set. Happy? So dx is 2 cosine theta d theta, and the root cubed is 6 cubed cosine cubed theta. So over here you have 3 6's, right? Because 6 cubed. Take one of the 6's, cut it in half to cancel it. So what you have is 1 over 36 times 3, because one of the 6's was cut in half. And then you have integral of d theta over cosine square. Oh, beautiful. Woohoo. Why am I happy? Because turns into secant squared, and that turns into tangent. So it's beautiful. 1 over 108, I hope. Right? Nah, it's good enough. Integral of secant squared theta d theta. And that's a basic integral that you are supposed to know from Calc 1. Integral of secant squared is tangent theta plus c. All you need to do now is to go into your triangle and read the tangent from the triangle. So 1 over 108, tangent is 3x over the square root. Plus c, and you move on with your life. Do I have to simplify 108 and a 3? You cannot move on with your life. Now you can move. Well, you still can't kind of move because you can factor a 9, which would give you a 3, which would bump it back on. I'm done. Let's do next example. $33. Buen. Integral of x squared divided by square root of 4 plus x squared dx. Excellent. Go on, you know what to do. Triangle.
You might as well get some fresh air. Because I can.
So what's the answer? 73. Good. No. You have to have plus C. Okay, 73 plus C. We start with a triangle. And in our triangle we have theta. We have a plus. The trick is to put x here and a 2 on the bottom so you can have your tangent. Otherwise, if you put x on the bottom, you'll work with cotangent. But you will get there. Square root of x squared plus 4 or 4 plus x squared doesn't matter. Red equation for the tangent and blue equation, hopefully for secant, otherwise we go home. Tangent theta is x over 2. X is 2 tangent theta. Dx is, anyone please help me? Thank you. D theta. Blue, we have cosine theta equals to 2 divided by the square root. And from there, square root is equal to 2 over cosine theta. So square root equals 2 secant theta. Observe that you have x squared. That means you are squaring everywhere in the red. So now we have integral of 4 tangent squared theta divided by square root is 2 secant theta, and dx is 2 secant squared theta d theta. 2 will cancel 2, secant will cancel one of the secants, and we have to deal with, kick 4 outside, we have to deal with tangent squared theta secant theta d theta. And whoever picked this problem, amazing pick, because now tangent squared is secant squared theta minus 1 times the secant theta d theta, which gives us our famous secant cubed theta minus secant theta d theta. This is where, you know, it's run for your life situation. Now, those of you who missed last class, I labeled these as the evil one, right? And I'm going to jump quickly over there so we can see the solution for these. So we're going to jump back to our trig integrals, and we are going to look for the evil one. There it is. I didn't label it? Really? There we go. Much better. So secant cube x to now the problem we have is a secant cubed minus single secant, right? So for us to integrate secant cubed, we have to do this. And then within the solution for secant cube, we get a secant single. And then we do this to figure out secant single. And then we plug everything. That's a secant single. And you can plug that there to come up with the answer. So now you will cut and paste this for secant cubed, and you will plug in what the secant x is, which is this over here. And then when all of that gets together, it's about 2-line solution. Then you go back into x by reading secants and tangents off of the triangle you have. "10,000 people. Hush." So these problems are all listed right for you in the previous section. I just don't want to copy everything, so there. Solution in 8.3 notes. Next problem. See, I solved this so fast. Let's do another one because we can. Don't forget to multiply by 4. After you have the 2-line solution, just times 4, okay? What else? 17. Sounds good. Integral of 64 minus x squared. I mean square root of dx. All right. First come, first serve. Go ahead, have fun. Okay.
You like always want the x to be on.
Yeah, because it gives you sine, gives you tangent. You put x down there, you might get cosecant. It's just being lazy.
It just makes it easier to use. Or simple.
So this type of a question is, exam, final exam, considered straightforward, cheap, easy. This particular one. Because, as you can see, all you get is the integral of 8 cosine theta times another 8 cosine theta d theta. So it's 64 integral of cosine squared theta d theta. And what do we know about this integral?
1 minus cosine 2 theta divided by 2.
1 plus cosine 2 theta divided by 2 d theta. And that's 32 theta plus sine 2 theta over 2 plus c, which is 32 theta plus 16. Now, guys, sorry, not 16, another 32. You cannot substitute 2 theta in. You have to break that apart using 2 sine theta, cosine theta, and then 2 and 2 will cancel. So it's 32 theta plus sine theta cosine theta plus c, and now you know that, well, 32 is going to be inverse sine of x over 8, plus sine is x over 8, and cosine is the square root. What was the square root? 64 minus x squared divided by 8 plus c. And yeah, we can multiply 32. So 32 sine inverse x over 8 plus 8, 4, 2. So x no copying square root of 64 minus x squared over 2 plus c. I'd say it's good. I noticed that you skipped over all of the definite integrals with values.
You didn't even show this.
I am. For there.
You
What?
skipped over them.
Yeah.
You skipped over them.
52. Wow, it's not 52 because it's a different edition of the book. So the problem is integral root 2 to 2, the square root of x squared minus 1 divided by x dx. Go. No pressure, you have 18 seconds. It's problem 26 in the new book.
Oh, are they? I don't remember that.
Four seconds left. All right, let's take a look at this together. So let's start by assigning the triangle again. I have a negative under the square root. Because I have a negative under the square root, that means that the first value here goes on the hypotenuse. That's how I know it's x. And then I get to pick any one of these for 1. And then the third one would be x squared minus 1 when you use Pythagorean theorem. So now we create red and a blue. And as soon as I look at the blue, these are, millions of years of experience. As soon as I look at the blue, I see cotangent. I'm going to switch the legs. Because I can work secant tangent pair. Because with a cosecant cotangent pair, it's the same formula. It's just minus signs all over the place. So, let's not. So I'm going to swap these. I'll put 1 over here and I'll put the square root of x squared minus 1. Because legs you can always swap. If you end up with a pair you don't like, you can swap the legs and it will immediately switch to the other pair. So now when I do the red and blue, they become secant tangent. So red is tangent theta, which is equal to square root of x squared minus 1 divided by 1. Well, okay, we're done. And the blue one is going to be cosine theta as 1 over x. So x is 1 over cosine theta, which is secant theta, which means that dx is very good. So now plug everything in. Instead of a square root, I have tangent theta. Instead of x, I have secant theta. And instead of dx, I have secant theta, tangent theta, d theta. And now I'm going to swap the limits as well, so I don't have to go back to x and compute. I can just compute with trig and be done. So the new part over here, orange, limits. You are allowed to use any trig formula to come up with the limit transformation. I need to transform root 2 and 2. So I use cosine theta is equal to 1 over root 2 for the bottom. Now when I rationalize this, I get root 2 over 2. So that works out to be pi over 4, because cosine of pi over 4 is root 2 over 2. Now cosine theta of 1/2, theta for 1/2 is what? Very good. Sine of pi over 6 is half. Cosine of pi over 3 is half. So now, one of the secants dies. Well, both secants die. And we have our integral of pi over 4 to pi over 3 of tangent squared theta d theta. How do I integrate this? Excellent.
1 minus secant square.
Yes. It's secant. So secant squared theta minus 1 d theta, and these are basic integrals. So I have integral of secant squared is tangent theta minus theta computed from pi over 4 to pi over 3. There's no plus c now because we are plugging values in. This is tangent of pi over 3 minus the tangent of pi over 4 minus pi over 3 plus pi over 4. Tangent of pi over 3 is, very good, minus tangent of pi over 3, excellent. And then you have minus pi over 12. That's good enough. It's about 0.5. Ta-da! See you in 2 days. Do a lot of homework.